All right, we are going to review sections 2.5 and 2.6 with lots of examples. These are examples we did in class, so if you were gone, this is what you missed. If you were there and you just need some refresher, this might be the spot because we're doing lots of examples. Okay, so we're factoring quadratics. Remember, a quadratic is in the form ax squared plus bx plus c, where the a, the b, and the c are numbers. They're constants. When we look at this example right here, the a is 1, the b is 3, the c is negative 28. Oh, I should look for a GCF. 1k squared, 3k, and negative 28 have a greatest common factor of 1. A is 1, B is 3, C is negative 28. We take A times C, we find the product of A and C, and then we look for two factors of negative 28 that add up to positive 3. Remember, the sum needs to equal B. So we need a positive factor and we need a negative factor for this to work. Negative 1 and positive 28 is going to give me a sum of 27, so that's not it. Negative 2, positive 14, that gets me a sum of 12. That's not it. And even if I switched it to a positive 2 and a negative 14, that still wouldn't work. Negative 4, positive 7. Notice the sum there is a 3, and the 7 is bigger than a 4. I need that because the sum is a 3. Positive 3. Okay, all those things we talked about in class or in the videos. At this point, we're going to build the table, the multiplication table that we're then going to deconstruct to find the factorization. Okay, we're going to do k squared. First term gets the first square. Last term of my polynomial gets the last square. So the negative 28 gets the last square. And the other two squares, we're taking the 3k and we're breaking up as a negative 4k plus a 7k, because we know that negative 4k plus 7k is going to equal 3k. Now we're going to find the greatest common factors of the first row, second row, first column, and second column. I'm going to change color here just for a second so you know what I'm looking at. I'm going to find the greatest common factor for k squared and negative 4k. That GCF is a k. Second row, 7 goes into 7k. It also goes into negative 28. That's a positive 7 since it was a positive 7k. Remember, the first expression in the row of the table determines the sign that I use. I'm going to switch colors again. I'll switch over to green. Greatest common factor for that column is a k. Greatest common factor for the second column, I'm going to do a negative since this is a negative 4, negative 4k. 4 and 28 have a common factor of 4, and the k is not there because 28 doesn't involve a k. All right, our factorization then is going to be k minus 4 times k plus 7. And we can use the table to check our answer. K times k is k squared. K times negative 4 is negative 4k. K times 7 is 7k. Negative 4 times 7 is negative 28. And if we add those four things together, it creates the polynomial that we started with, the quadratic we started with. All right, next example. 5x squared plus 21x plus 4, we're factoring that. Now look for a GCF. 5x squared, 21x, and 4. They do not have an x in common. They do not have anything in common other than a 1. Look at the 5 and the 4. No common factors other than 1. So next thing we're going to do is we're going to identify the a, the b, the c. We're going to calculate a times c. 5 times 4 is 20. We're going to look for two factors of 20 that add up to or that have a sum of 21. And they're both going to have to be positive in order to get a positive product and a positive sum. 1 and 20, yep, they're going to work, because 1 plus 20 is 21. Got it on the first try. We'll build the table. First term gets the first square, last term gets the last square. The middle term gets split into two pieces, an x and a 20x. We'll find the greatest common factor of the top row. 5x squared and x have a greatest common factor of x, looking just at the top row. Bottom row, 20x and 4 have a common factor of 4, and we're going to do a positive. Oh, whoops. What did I write in there? Oh, no, that's right. Momentary brain freeze. Okay, first column. Greatest common factor for 5x squared and 20x is 5x. Greatest common factor for x and 4 is 1. And we have our factorization. 5x plus 1 times x plus 4. And we've got our answer. I don't like that parenthesis. Still don't like that parenthesis. Moving on. Next question. Factor m squared minus 2m minus 3. All right. A is 1. B is negative 2. C is negative 3. Did I check for a GCF? I did. It's just so automatic. I just do it without thinking about it. M squared, negative 2m, and negative 3. Only common factor they have is 1. Identify the A, the B, and the C. Find A times C. That's 1 times negative 3. Realize that we need 2 factors of negative 3 that add up to negative 2. So they have a sum of negative 2. Negative 1, positive 3. I need a negative and a positive to get a product that's negative. So negative 1 times 3 is negative 3. But the sum there is a 2, and I need a negative 2. If you're off by just a positive or negative sign, and you have opposites here, I think we have a negative 1 and a positive 3, just switch them, and the sum will be what you need. So we have a 1 and a negative 3. We're going to build the table. M squared, negative 3. Remember, first term gets the first square, last term gets the last square, and then the middle term gets split into two pieces. We've got an m, and we've got a negative 3m. And it won't matter which one I put in which of those empty squares. All right? Using that right there. Okay, so GCF for the top row is m. Greatest common factor for the bottom row, negative 3. Remember, this negative controls the sign. M squared and negative 3 in that first column. Greatest common factor is m. The last column, m and negative 3. Greatest common factor is 1, and it's going to be a positive that I use because that's a positive in front of the m. Our factorization then is m plus 1 times m minus 3, and we can check that this works because our multiplication table would tell us so. All right, next question. Factoring 6b squared minus 7b plus 2. Look for a GCF. It is 1. 6, 7, and 2 have a greatest common factor of 1, and not every one of these terms has a b, so we don't have a b as a common factor. We're going to identify the A, the B, the C. We're going to calculate A times C, which is going to be positive 2. I'm going to look for 2, oops, what? Positive 2. 6 times 2 is still 12. Hello. We are going to look for 2 factors of 12 that add up to negative 7. And if you see it right away, then write it down right away. They need to be negatives in order to have a positive product and a negative sum. -3 and -4 will work. -3 times -4 is 12. -3 plus -4 is -7. So if you see the right combination right away, if it just jumps out at you, just write it down and don't write any other possibilities. I'm okay with that. All right, create the table. 6b squared and 2. First term gets first square, last term gets last square. Middle term gets split into two pieces, -3b, -4b, which add up to the -7b. We're going to find greatest common factors. 6 and 3 have a common factor of 3, but we also have a b that they share. Notice it's a positive 3b. 6b squared and -3b. 3b is what we're going to use. Okay, second row, -4b and +2. 4 and 2 have a common factor of 2, but we have to take a negative. First column right here, 6b squared and -4b. Greatest common factor there is 2b. And then for the last column, greatest common factor there is 1, but I need to take a negative because that first term has a negative. All right. Moving on to the answer, 2b minus 1 times 3b minus 2. Now remember, we can check our answers by looking at the multiplication because this is a multiplication table that we peeled apart. 2b times 3b is 6b squared. That checks. 2b times -2 is -4b. 3b times -1 is -3b. And -2 times -1 is +2. Do all those four things add up to what we started with? -3b and -4b add up to -7b. Yep, it works. Okay, moving on. Things to remember. If you have a negative leading coefficient, you need to factor it out. If you have a greatest common factor, you need to factor it out. If you have both a negative and a GCF, you're going to factor it out first. Okay, so I'm looking at this. I have a greatest common factor of 1, but I have a leading coefficient that's negative. It's a leading coefficient of -1. We're going to factor it out. Okay? So negative leading coefficient, factor it out. So we take the negative. Remember, as we factor out the negative, everybody inside the parentheses is going to have opposite signs because we're dividing out a -1. You can pencil in a 1 there if you want to. We're dividing out a -1. So -x squared divided by -1 is x squared. -2x divided by -1 is +2x. And 35 divided by -1 is -35. Now we're going to focus on the quadratic that's inside the parentheses. So we now have a equals 1, b equals 2, c equals -35. And we're going to calculate a times c, which is exactly equal to c. I need two factors of -35 that have a sum or that add up to +2. So I'm going to have a negative and a positive. And if you think about the number combinations, or you go through one at a time until you find the one that works, you have -5 and +7. We'll build the table. I think I'll come over here to build the table. First term gets the first square, last term gets the last square. Remember, I'm working on the quadratic that's inside the parentheses. I'm ignoring the -1 till the very end. I'm taking the middle term 2x and I'm writing it as -5x plus 7x. And then we're going to find greatest common factors of each row. Top row, bottom row, first column, second column. Remember, the sign of this guy controls the sign that I use out here, whether it's a positive or a negative. So we're going to do x minus 5 times x plus 7. And if you enter this answer, it will be counted as wrong because we need to remember at the end to put our negative back in front. All right, next example. We have a couple more. Factoring 5k squared minus 5k minus 30. First thing I want you to notice is we do have a common factor of 5. So the first thing we're going to do is factor out that GCF. Pull out the 5. We have k squared minus k minus 6, because 30 divided by 5 is 6. And notice the signs. If we redistribute, everything works. Okay? 5k squared divided by 5, divide by 5, divide by 5. That's what goes inside the parentheses. We're dividing out a 5. Remember, factoring is undoing multiplication, so we're dividing them out. Now work with the quadratic inside the parentheses. A is 1, B is -1, C is -6. We're going to do A times C and get -6. We're going to find two factors of -6 that have a sum of -1, right? Let's see. One needs to be positive, one needs to be negative. Oh, that's going to be the wrong sum. It's even the wrong sign. So if I switch to a positive 1 and -6, that's not going to work. If I do a 2 and a -3, notice the negative has to be with the 3. That will get me the right sum. Okay, so there's the one we're looking for. We're going to build a table. We're going to put the first term in the first square, last term in the last square. Middle term gets to be split into two pieces. Greatest common factor for the top row, for the bottom row, for the first column, for the last column, and then factors k plus 2, k minus 3. Again, if I enter that as my answer, it will be wrong because I need to remember that I pulled out a 5 as a factor as well. And there's the answer for that one. Okay, next example, p squared minus 16. Factor it. It is a quadratic, but it only has two terms. It's a binomial rather than a trinomial, but we can look at it as having a middle term of 0p. So we look at it this way. We have a equals 1, b equals 0, c equals -16. This is going to be a skill we need to understand, or a technique we need to understand, that b is 0 in this case. A times c, we'll calculate that. That's going to be -16, because 1 times -16 is -16. I need to find two factors of -16 that have a sum of 0, so we need to add them up to 0. Think about that. If two things add up to 0, oh, how's that going to work? One needs to be positive, one needs to be negative, and it will only work if they are the same number with opposite signs. So like 4 and -4 is our combination that we're looking for here. 4 plus -4 is 0. And 4 times -4 is -16. So what we have, this is only working because 16 is a perfect square. 16 is 4 times 4. We've seen examples where we did it with 49, with 25. Only works for perfect squares. First term gets the first square, last term gets the last square, and in the other two, we do a 4p and a -4p that will add up to 0, right? Greatest common factor for the top row, for the bottom row, for the first column, for the second column. And our answer is p plus 4 times p minus 4. We didn't have anything that we pulled out at the beginning, so we've got it. Okay, next question. -22m squared plus 29m minus 9. This is what we did on the 28th and the 29th in my classes. All right, so I'm going to notice I have a negative that I'm going to have to pull out. Do I have a greatest common factor that I need to pull out as well? 22m squared, 29m, and 9. Do they have a common factor? Nope. Not other than 1, they don't. So we'll pull out a negative or a -1. If you want to pencil in a 1 there, you can. As we divide out the -1, everybody changes to the opposite sign. Multiplying by -1 and dividing by -1, they do the same thing. All right, so now we have A equals 22, B equals -29, and C equals 9. We're going to calculate A times C. 22 times 9, which is, I'm going to grab a calculator and do that, 198. I'm going to look for two numbers that multiply to create 198, but they have a sum of 29. That sum of -29. It's important. It's negative. And I'm going to, 198 is big. I could do, well, they both have to be negative. I could do this, but that's going to be way too big of a sum. Or I should say way too small, -199. It's divisible by 2. So 198 divided by 2 is -99. That's not it. Can I divide out of 3? Yes, look at these factors. 22 times 9. There's a factor of 3 in that 9. And we're going to do a little creative math here. In that 9, if I take a 3 and push it over, 66. 3 times 22. Or I can grab the calculator. I can do 198 divided by 3 and find out that it's 66. -3 and -66 don't add up to the right thing. Is my 22 times 9 divisible by 4? No. Is it divisible by 5? No. Divisible by 6? Yes. And you can either do 198 divided by 6, or you can do a little creative math and take a 2 and shuffle things around. It's probably just as easy to do 198 divided by 6, which is 33. Still not the right sum, but we're getting closer. We need -29. We got -39. Is 22 times 9 that 198? Is it divisible by 7? No. By 8? No. 9? Yes. We're still a little off. Is it divisible by 10? No. 11? Yes, because 22 is divisible by 11. If we do 198 divided by 11, or we do a little creative math and we take a 2 from here and push it over with the 9, we have 11 and 18. That adds up to -29. Okay. So we're going to build our table. I'll just build it over here since this is where I've got room. First term gets the first square, 22m squared. Last term gets the last square, and the middle term, the -29m, gets to split into -11m and -18m. Greatest common factor for the top row, 11m. 22 and 11 are both divisible by 11. Bottom row, -18m and 9. That's going to be -9. First column, so I'm looking at these guys right here. First column, we have a greatest common factor of, let's see, 2 goes into 22 and it goes into 18, yep. And we have an m. Last column right here, greatest common factor is 1. 11 and 9 have a common factor of 1, but there's a negative there because this is a -11m. So our factorization is going to be 2m minus 1. That's this factor. And then the 11m minus 9, that's this one. Okay. But we need to remember at the end here that we pulled out a negative at the beginning of the problem. There's our answer. All right, last example. Factor 9x squared minus 42x plus 49. We've got some big stuff going on here. 9x squared, 42x, and 49. Is there a greatest common factor other than 1? I'm going to say no. 9 is 3 times 3. 49 is 7 times 7. We don't have any factors in common. GCF of 1. Okay, A is 9. It's the coefficient of x squared. B is negative 42. It's the coefficient of x to the first power. And C is 49. Okay. We're going to do A times C. 9 times 49, which is 441. Just 9 short of 450. And then we're going to look for two numbers that multiply to create 441 and have a sum of negative 42. Remember, B is the sum. They're both going to have to be negative factors that we're looking for. So we could do negative 1 and negative 441, but that's ridiculous. That's going to add up to negative 442. 441 is not divisible by 2. It's not divisible. Oh, it is divisible by 3. How do we know that? Because we have 9 times 49. Well, that's not going to work. It's going to be way too big. Way too far from negative 42. But you can write it down if you want to. Okay, is it divisible by 4? No. 5? No. 6? No. 7? Yes. 7 and 63. Because 441 divided by 7 is 63. Or you can move numbers around right here. Divisible by 8. No, we're not even going to try evens. 9, yes. That's not it for the sum. 10, 11, 12, 13, 14, 15, 16, 17. Look, I'm not going to have anything until I get to 21. Look at the factors. 3, 3, 7, and 7. Nothing even works. The only primes that work are 3 and 7. We don't have anything until we get to 21. Negative 21 and negative 21 add up to negative 42. We'll build our table. First term gets the first square. Last term gets the last square. Middle term gets split into 2 pieces. Greatest common factor for each row. Top row has 3x, bottom row has negative 7. First column right here, the 9x squared and the negative 21x. First column has a 3x. Second column, negative 21x and 49 have a common factor of 7. I take the negative with it. Look at what we have. We have the same factor twice. Oh, preview of what's to come. 3x minus 7 times 3x minus 7. That's my answer. Again, I don't like my parentheses. 3x minus 7 times 3x minus 7, but we also need to recognize that that could be written as 3x minus 7 squared. And that is the last example we're doing.